Hey guys, this is Miss Mo. This is exam review number 3. We're coming up on our third test. And exam 3 covers 10.1 all the way through 12.5. Alright, and don't forget that you have to do the online test review with above a 70 to gain access to the test. And just FYI, those of you who finish this test review in 12 minutes and then you get a 12 on the test, that's probably why you got a 12 on the test. So, please don't rush through this review. Please don't use PhotoMath. As you're doing this review, please do it on your own, because when you go to take your test, you're on your own. Okay, so let's see here. Number 1 says use a calculator and evaluate A to the nearest cent. They gave us a formula, and they said T equals 2, 3, and 10, and they said round to the nearest hundredth. Okay, so we're going to take this number 2, and we're going to plug it in where the T is. Then we're going to do it again for the 3 and the 10. And we're going to put it in our calculator and round to the hundredth. So we're going to have capital A equals 14,000 E to the 0.1 times 2. Then we're going to do it again and put a 3 in the air. Then we're going to do it again and put a 10 in the air. Oops. Alright, and there is no way you can do this without a calculator. So if you do not bring a calculator, good luck. You might need to call the testing center and see if they have one that you can borrow. I know the Greenville campus has like 5, 7, something, a couple of calculators that you can borrow. So you can always do it there. So, we either need our handheld calculator, or if you don't have one of these, call the testing center, and they should have some to borrow on the day of your test, okay? If you don't have one of these, then get out your phone. Don't judge my phone, okay? Okay, get out your phone and go to your app store and purchase this. Calculate 84. It's actually free. It might say something about $2.99 for the first 3 days or something like that. Just press cancel or X over and over and over. So this Calculate 84 is free unless you press some extra buttons. Okay, so you can download that, and you can download that to your iPhone or to your Android. Okay. So here's the graphing calculator, and I'm just going to go to my blank screen. And if you're in something and you want to get out of it, you can always press clear a bunch. Yeah, okay. Okay, so we're going to go to our blank screen, and we're going to type 14,000 E. E, you find by pressing the blue second and then LN. Same thing on the phone. The blue second, and then the LN, and an E pops out. Okay, then in the air we have 0.1 times 2. On the phone, let's see, 0.1 times 2. Hey, okay, and we got 17,099.638. Okay. Let me go ahead and write those down. So we got 17,099.63, and that's how much money usually has. With cents, we usually only have 2 decimals, but we need to round. So I'm going to go ahead and put a third decimal down, that ocho, and then now let's round like money, honey. Okay, money only has 2 spots after the decimal. So what does that ocho make that 3 go up to? The ocho makes the 3 bump up to a 4. So we got 17,099 0.64. Hey, that's how much money we would have in the account, or after using that formula. Okay, let's do it again, but for 3 in the air. Okay, so there's something really awesome. We could either try typing it all over again, 14,000, yeah. Or if you wanted to, you could press second, enter, and it'll pop up what you've already typed in. Whoops, and I've already typed in 14e to the blah, 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 blah. So it just pulls it back up for you. I'm going to stop using that. Okay. So if I want to pull back up what I wrote, you can either rewrite it again, or I can press second and enter. Hey, and then I'm going to use these arrow buttons. And I pressed delete, and then I'm going to type a 3 there. Yeah, and then I'm going to do it again with a 10 in the air. And again, you can either retype it, or press that second enter. Okay, so for the 3, I got, let's see, 18,898.023. And then let's round like money, honey. Rounding like money means you only need 2 decimal spots. So this is going to be 18,898.0, and then is this 2 going to stay or bump up to a 3? Well, the number next to it, 3, is 4 or less, so we're going to let that 2 rest. Hey, okay, I already plugged in the 10, and I got 38055, what does that say, 0.945 maybe? Okay, but with money, we got to round it to 2 spots. So that 5 is 5 or more, so we're going to up the score. So this 94 is going to become 95. All right. Okay, so again, there's no way you can come up with these answers unless you have a calculator. And if you don't have a handheld calculator, call the testing center. They should have extras for you to borrow on the day of the test. Until then, use this free app on your phone called Calculate 84, and it's free. Do not pay for anything. Okay. All right, let's look at number 2. Number 2 says something about present value. A promissory note will pay $45,000 at maturity 9 years from now. How much should you be willing to pay for the note now if the money is worth 4.25 compounded continuously? Okay, a promissory note is kind of like when you go get a loan. Okay, so this is saying you went to the bank and you got a loan that will, or maybe not a loan. Let's say maybe not something that you have to pay off, something that you pay into. Let's say a promissory note is like a savings account. But it's a specific savings account where you let it sit there for a while at a certain percentage rate. I think your savings accounts at banks, the percentage rate that it increases every year is ridiculous. It's super small. Like, you barely make any money. But you can get a special savings account, or you can put money into an account and it will grow. So let's say that this account will have $45,000 at maturity 9 years from now. So that means I put money into the account today, and 9 years later, I have $45,000. Oh my gosh. And it says, how much should you be willing to pay for the note now if the money is worth 4.25% compounded continuously? Okay, so So, we're going to use that same formula that we used on number 1, only now it's not already set up for us, so we have to set it up. So let's use this A per. Okay, and let's figure out what all these numbers are. It says $45,000 is the maturity. That's the number at the end. So that's our A, or that's the accumulated value. The 9 is the T, because it's time. The percentage is the R, but we have to move that decimal twice to the left. Oh no. Because our calculator cannot handle typing in a percentage. Our calculator can handle typing in a decimal. So since this 4.25 has a percent sign on it, we need to take that decimal and move it twice to the left, and it becomes 0.0425. Okay, then continuously means we use an E in our formula, which is already there, and then it says, what's the note now? So how much money would you put into the account now to make $45,000 9 years from now? Okay, the note now, that means the letter P. Okay, so let's see here. Our A is $45,000. We don't know our P. Our E is the letter E. It's a button in your calculator. The R is 0.0425. The T is 9. All right. And then you might not can tell, but everything from the E to the 9, you can put that in your calculator. Okay, so let's do it. We're going to do that. Let's see here. We're just going to do the E to the 0.045 times 9. And remember, to get that E, you press second LN. So second LN, I got the E. Now let's do 0.0425 times 9. And I got 1.4659. Yeah. Okay. So we get 45,000 equals P. And then that E junk is now 1.4, what was it? 659. Okay, the question is, what is this P doing to this E? Because whatever those are doing to each other, that's the symbol I need to put in between this P and this 1.4 blah, blah, blah. So, look back at your original formula. When two letters are squished up next to each other, that means multiply. Just like up here, the R and the T meant multiply because they were squished. P and E mean multiply because we're squished. So there's technically a multiply dot after this capital P. Multiply dot. Okay? Well, let's think about this. We're supposed to be getting the letter P by itself. How can we get the letter P by itself if right now it's multiplying with a decimal? What's the opposite of multiplying? And the answer is dividing. So we're going to divide both sides by that decimal. So in our calculator, we're going to put 45,000 divided by 1.4659. Let me make sure I typed it in right. Yep, I did. Okay, so we get... We were solving for the letter P. Remember, because there was a P over here? Yeah. And we got 3697.864. But this is talking about money. And when we round money, we only want 2 decimal spots. So this 4 is 4 or less, so we're going to let the 6 rest. So the question was, how much money has to be in the account now for you to have $45,000 in 9 years? Well, it means you have to deposit $30,000 today, so that 9 years from now, it will grow to $45,000. Yeah, I don't have that kind of money to put down today. I don't know about you. All right, let's go to number 3. Number 3 and 4 are talking about, they give us the price-demand equation, and it's asking for the EP, the elasticity of demand. Okay, and the formula for the elasticity of the demand is right here. Let's see. It's capital E parentheses P equals big fat negative fraction bar P times the derivative of f of P all over normal f of P. Okay. So, it's kind of awkward because of the F's and the E's, but it's okay. Okay. The f of P, they already gave us. It says x equals f parentheses P equals 7,800 minus blah, 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 blah. Yeah. That sucker is going to go in the bottom where it says f of P. Yep. So half of that formula they already gave us. Exciting. Okay. This P is always a P. It just always put a P. Always a P. Okay? And then this F prime sucker, well, that's the derivative. Okay, so the only super math we have to do is the derivative. So let's find the derivative. The derivative of this is the derivative of a number, just goes away to 0. Then the derivative of negative 6p squared is you take the 2, bring it down, and multiply. 2 multiply negative 6 is negative 12. P to the subtract 1 from the exponent, 1. So this was from that last test. So this is the derivative, or this is our f prime of P. Yeah. Okay, so since that's the only real math we had to do, let's put it all back together. We're going to have a negative on the side from the formula. We're going to always put the letter P. Always put the letter P. We're going to put a multiply dot. Multiply dot. Then we're going to put the derivative, which was that negative 12p to the 1. Then on the bottom, we're going to put the FP, which is the original thing they gave us. 7,800 minus 6p squared. Okay, the next thing we're going to do is we're just going to kind of clean up. All right, the way we're going to clean up is we're going to say negative times this negative 12. Because on the top, that doesn't say p minus 12, it says p multiply. So let's go ahead and multiply. This negative times negative 12 makes plusative 12. Then p times p makes p to the squared. Because it times itself is squared, p times p is squared. And then let's keep all that stuff on the bottom. Alright, the last thing that you're going to do is you're going to reduce. What do you think we could reduce all three of these numbers by? Probably 6. Let me see if 7,800 can be divided by 6. Oh, yep, 1,300. So we're going to divide by 6. And we get 2 p squared over that 7,800 divided by 6 was 1,300, minus 6 divided by 6 is 1, or you don't even have to put the 1. Or you can. It doesn't really matter. Okay, so you can either keep this as your answer, or you don't have to write the 1 if you don't want to. Alright, let's go to number 4. It says use the price minimum to find E of P, the elasticity of demand. Okay. Same blue formula up here, where the very first thing we have to do is find the derivative. Alright, let's find the derivative. That's the f prime of P. Okay, well, in this original equation, naked numbers, the derivative of a constant of just one single number is 0. So it goes away. The derivative of something with a e is the exact same thing. You might have remembered back in the day, if you have f of x equals e to the x, then you have, if you try and find the derivative of e to the x is just the same thing, e to the x. So for us, the derivative of this sucker with the e is the exact same thing, sucker with the e, negative 0.6 e to the p. Okay, so that's our derivative. Now let's throw it all into this formula. This formula says big old fraction, negative in the front, big old negative in the front, p, and we wrote it's always a p, so we always put a p there, multiply dot, f prime of p, that's the derivative, and heck fire, we just found that. It's this negative 0.6 e to the p, okay, yeah, negative 0.6 e to the p. So this is a decimal on the 0.6. This dot by the p, that's a multiply dot. Okay, all over f of p. And that looks like they already gave it to us. 93 minus, yeah, let's write that down. On the bottom, 93 minus 0.6 e to the p. Okay. Ooh, this is kind of scary. This one's a little awkward because of the e, but we're going to do it same way we did this problem on the left. This problem on the left, the way we got 12 was we took the negative in front of the fraction and multiplied it by that number on the top of the fraction. So the negative in front of the fraction times that negative 0.6, what do those make? Negative times a negative is a positive. So we have positive 0.06. Okay. Then let's see what we did on this last problem. On this last problem, I got p squared because p times p is p squared because it times itself is squared. But let's look up here. We don't have p times p. We have p times funky thing with a e. Okay, so we cannot say it times itself has a tiny 2 in the air because this is not it times itself. This is p times something janky. So let's just squish all the janky stuff together. We have 0.06, then p, then e to the p. That looks like 0.06 pep. But if you look at the answer has pep in it. So we're doing okay. Okay, all over the bottom, 93 minus 0.6 e to the p. Okay, on the last problem, the next thing we did is we tried and reduced. Let me see if I can divide this 93 by a 0.6 and it come out to be a whole number. Oh, 155. Okay. Okay, so that means we could divide all 3 three of these numbers by 0.6. So let's reduce. And if I do, oh, my bad. Oh, is it 0.06? I think this dot's in the wrong spot. Oh. Yeah, on the top, it's supposed to be 0.6. My bad. I wrote 0.06. Let me erase that little... Okay, there we go. Woo! Back to normal. Alright, so you can divide all these by 0.6. And on the top, when you divide 0.6 by 0.6, those cancel, and you just get PEP. On the bottom, when you divide by 0.6, I think I already did the 93. 93 divided by 0.6 is 155. Minus 0.6 divided by 0.6 is just 1. E to the P. Yay! Okay, on your test, when you take it, if you're kind of close, then I'll give you a lot of partial credit. So this is kind of awkward to type in, and if it looks pretty close, then I'll give you a lot of partial credit. So if you're not sure how to type it in, just try, and I'll give you partial credit. Alright, let's keep going. Number 5. Number 5 says some hoopla about find f prime, then the partition numbers, then the critical numbers. And they gave us an equation. Okay, well, let's start out with part A, because we know how to do that. Okay, f prime. That means the derivative. Let's go. F prime of x equals. Take the exponent, bring it down in front, and multiply. 2x. Subtract 1 from the exponent. What? Okay, the derivative of a number x just goes to that number, minus 12. And then the minus 3. I wrote this problem wrong. This problem is supposed to start with a 3 in the air. Idiot. Golly. Okay. So that makes 3x. My bad. Typo. I wrote it down wrong. It was supposed to be x to the 3. Okay, anyway. So to take the derivative, you take that 3, bring it down in front, and multiply it. 3x. Subtract 1 from the exponent. Okay, good. Then the derivative of a number in x just goes to that number. And what about a naked number? The derivative of a constant or a naked number is just 0. That was on that last test. Okay, so we found part A, the derivative. Huzzah. Okay, part B says partition numbers. Okay, for this partition numbers, we can either do something called factoring, or we can look in our T-chart, in our graphing calculator. And since we have to have this graphing calculator for the test, I'm going to go ahead and show you how to do the T-chart. Okay? When we go to our T-chart, we are going to be looking for what numbers are in the X that give me bad boy zeros in the Y's. That's what's called a partition number or a critical number. Okay, so we're going to go to our calculator and we're going to put the derivative into y equals. So we're going to go to y equals. Y equals is this top left. So we're going to go to y equals. And if you have anything in there, clear it out. And I'm going to type in the derivative, this 3x squared minus 12. Okay. Then I'm going to go to the table. Table means T-chart. See how the table is in blue? So you're going to press the blue and then the graph button, and we get a T-chart. Okay. Now we're going to look for the zeros. You can either press up and down, or on the phone, yeah, you have to press up and down too. Okay. So we're trying to find what has a 0 across from it. See? What has a 0 across from it. And we see that there's a 2, and oh, there's another one, -2. Or on our handheld, -2 and 2. Okay. All right, so we put this sucker in y equals. Then we pressed second graph. And we saw -2 has a 0 and 2 has a 0 across from it. Those are our partition numbers. And they're also our critical numbers. Okay, so part A was find the derivative. Then it said, what are their partition numbers? Partition numbers are x equals this -2 and this 2. Okay, as for critical numbers, they're exactly the same unless we started out with a crazy fraction. And we did not start out with a crazy fraction at the beginning of the problem. If we would have started out with something that looks like this with a crazy fraction, then yeah, the partition and the critical numbers would be different. But we did not start out with a fraction, so we don't have any crazy asymptotes or anything. So the critical numbers will just be the same as the partition. And it's going to be like that on the test too. So you might want to write that down, same as partition. And I'm not going to give you something funky on the test. Okay, so we did number 5. Let's go to number 6. It's asking for the increasing, decreasing intervals and any local extrema. Okay, increasing, decreasing, and local extrema means we need to, number 1, take the derivative. Number 2, look in our T-chart for zeros in the y's. Then we need to make a number line. Then we need to plug numbers in. Yeah, okay, well, let's go for it. Let's find the derivative. This 4 comes down and multiplies with the 2. So we get f prime of x equals 4 times 2 is 8. Subtract 1 from the exponent, 3. Keep going. Exponent times the number in front. 3 times 8 is 24. Subtract 1 from the exponent, 2. And then naked numbers or constants just go to a 0. Alright, so we got our derivative. Now we can either factor or use our T-chart. I'm just going to use our T-chart. Alright, so we need a T-chart from our calculator that has zeros in the right and something in the left. Okay, to do that, I'm going to go to y equals, and I'm going to type in not the original, not the thing with the 4 in the air, but what I just did, the derivative. And then I'm going to go to second graph. Okay, and if you're wondering how to do this by hand without a calculator, without this y equals second graph, you can go back and look at the videos for, what section would this be? 11.1. And it should tell you how to do them by hand. Okay, so either way, let's type this in. get that 3 in the air, you're going to use this caret button above the divide. Even on the phone, there's the divide, and above it is a little caret. That's what you would use. It means raise the roof and put an exponent up there. So I got 8x. Then I press the caret, raise the roof, okay? And now it's 3. But then I have to get back down, so press the down arrow, and 24x squared. Oh, I forgot a plus sign. Alright, okay, then we're going to press second graph. There it is. Okay, and let's look for the numbers that have a 0 across. I see a 3 and a 0. Okay. Okay, so let's see here. We took our derivative. We did our t-chart. Yes. Now we have to figure out the increasing and decreasing intervals. So I'm going to draw a number line. And I'm going to put these critical numbers of 3 and 0 on the line. 0 comes first, then 3. Okay. Now I'm going to pick numbers in between and outside each of the 0 and the 3. So a number in between those would be 2. A number to the right would be 5 or 4. Who cares? A number to the left would be -1. Okay. Now, we're going to plug these numbers in to the derivative. Or, since we have a t-chart, we're just going to look at the t-chart. Okay, so let's go back to that t-chart, and I want to know what numbers are across from -1, 2, and 5. Okay, let's go. This is not the right one. Let's go back and look. -1 is a 16, 2 is a 160, 5 is a 1600. Okay, all 3 of these are positive. So that means I'm going to draw an up arrow for all 3 of them on my picture. So let's go to my picture, my number line. For -1, oh, -30, idiot. Oh my god. Oh, no, no, no. I drew my number line wrong. Goshly. Okay, let's redraw my number line. I got 0 and -3. Gosh, why didn't y'all tell me? Okay, and then we pick a number all up in here. So a number to the right of 0 is like 2. A number in between is like -1. A number to the very left of -3 is like -4. Okay, so forget about all this hooey because I didn't put the negative on the 3. Golly. Okay, now we can either plug these numbers into the derivative by hand, as in 8 parentheses -4, close parentheses cubed, plus 24 times -4, close parentheses squared. Yeah. We could either plug that in our blank screen of our calculator, or we could just look at our t-chart across from -4. And in our t-chart, across from the -4 is -128. And that would have been what this was when I plugged in that -4. So you can either plug it in by hand, or we can just look at the calculator. Since it's the test, I'm trying to teach you some time-saving tips. Okay, then across from the -1 and the 2. Let's see. Across from the -1 is 16, and 2 is 160. Okay, so 16 and 160 are positive, so we're going to draw an up arrow. But that negative 128 is negative, so I'm going to draw a down arrow. Okay, so on top of that negative 4, since when I plugged in that negative 4, a negative 128 popped out, I'm going to put a down arrow on top of that negative 4. On top of the negative 1, an up arrow. Yeah. On top of that 2, an up arrow. Oh gosh, okay. Yeah. And those come from the symbols, the signs of the y values. Alright, we can now tell which is increasing. Increasing are the up arrows. Where do the up arrows start? They start at negative 3 all the way to the right at infinity. And we use parentheses always. Okay, the decreasing, let's see, it looks like it's to the left of negative 3. So to show that, we say negative infinity, because that's the number on the very, very left at the end of the line, all the way up to negative 3. Hey, those are our increasing and decreasing intervals. Yeah. Okay, the last thing that it asked us to do was find the local extrema. Okay, well, the local extrema come from these numbers from the first t-chart with the zeros, negative 3 and 0. Okay, and it's an extrema if it's the bottom of a valley or top of a mountain. So the last question said extrema. Well, it's only extrema if it's the bottom of 2 arrows, or if it's the top of those 2 arrows. It's either the bottom of a valley or top of a mountain. Okay, so let's see here. Do we have 2 arrows pointing up at each other? No, no. So we do not have a maximum. We don't have one of those. Okay, do we have an arrow pointing down then up? Yes, we do. And that's our minimum. Okay, so we definitely have a minimum at the bottom of that down up arrow. Down up at negative 3. Okay, the only thing is I need its y value. Okay, for its y value, we're going to take this negative 3 and plug it into the OG. So far, all we've done is gotten the derivative. Look at its t-chart. Drew a number line. Look at the same t-chart. Now we're going to look for the y value at negative 3. So you have to plug it into the OG equation. The OG is this 2x to the 4th. Yeah. So let's plug in negative 3 into the OG equation, wherever the x's are. 2, parentheses negative 3 to the 4, plus 8, parentheses negative 3 to the 3, plus 33. And then we're going to put that in our blank screen. Two, parentheses negative 3, parentheses raise the roof, caret, 4, drop back down, plus 8, parentheses negative 3, close parentheses, raise the roof. Oh my god, I didn't drop back down. Poop. Oh, poop. Okay, let me try again. 2, parentheses negative 3, parentheses raise the roof. 4, then drop back down. How do I? Okay, there we go. Plus 8, parentheses, negative 3, parentheses, raise the roof, 3, then drop back down, plus 33. Woo, I got negative 21. So that's the y value of the local extrema. So we have a minimum at negative 3, negative 21. So we had it increasing, negative 3 to infinity, decreasing, and then that local minimum at negative 3, negative 21. All right, let's keep going. Let's look at this number 7. This time it's talking about concavity. Number 7 asks, what intervals on the graph is f concave up? The intervals on which we are concave down, and the inflection points. Yeah, okay. So, when it says concave up and down, it's different from increasing and decreasing that we did already. Concavity comes from the second derivative. So for concave, we're going to have to do the derivative, then the derivative again. Then we do the t-chart and look for the zeros with that second derivative. Then we make a number line with those numbers from the second derivative's t-chart. Okay, let's go for it. We got to find the derivative. So this 6 comes down in front and multiplies. And we get f prime of x equals negative 6x to the subtract 1. 5 plus, take the 5 and bring it down in front. 5 times 18, 90. Okay, so positive 90, x to the subtract 1, 4. Then a number, x, just goes to that number, minus 18, and then a constant or a naked number goes to 0. Okay, so that's the first derivative. We did it. Yes. Now we have to take the derivative again. Okay, so now we're on the second derivative. We take that 5 and bring it down in front, and we get negative 30. X to the subtract 1 from the exponent, 4. Plus, bring down that exponent 4 and multiply it in front. 4 times 90 is 360. Subtract 1 from the exponent, 3. The derivative of this naked number, 18, goes to a 0. Alright, so we took the derivative. Then we took the derivative again. Yes. Now we're going to look in our t-chart. Okay, and when we go to our y equals, we're not putting in the OG original or the first derivative. We're putting in the second derivative. You always use the second for concavity. So we're going to type in that negative 38, and then you're going to press second graph. So y equals clear, negative 30, x, raise the roof, 4, get back down, okay, plus 360x, raise the roof, 3. Then press second graph. All right, and look for when there's zeros in the y's. Ooh. There's one. There was another one at 12. Let me go check negative 12 just in case. Yeah, code. That's all the zeros. Okay, so we had 0 and 12. Both had zeros across from them. All right, so now we're going to draw a number line and put 0 and 12 on it. 0, 12. Pick numbers in between. 5. Pick numbers after. 13. Pick numbers before. -1. Look in that T-chart of yours that we just had. What's across from the -1, 5, and 13? -390, -26250, 13 was -65910. Okay, according to the symbols is how we're going to draw our arrows. So since this -390 is negative, we're going to draw down, decreasing. Then the 26 is plusative, so we're going to draw up, increasing. Then the 65 is down. Okay, so let's draw our arrows. We're going to have down on top of the -1. Then up on top of the 5. Then down on top of the 13. All right. This is asking for concave up and concave down. Concave up is whatever has the up arrow. So up in this middle. And it starts from 0 to 12. You don't put this 1, 5, 13. All we did, we used those to figure out what kind of arrows we're going to draw. When you write concave up and down, you use these numbers from the original T-chart. Okay, so we're concave up from 0 to 12, and that's the only up. Now let's talk about concave down. Okay, well, definitely over here on the left, I see a down arrow from -infinity to 0. Then I see another down from 12-ish to infinity. Yes. Okay, so the point of this problem was to find the concave up and down intervals. We did. Yep. Okay, now it's time to find the inflection points, but on this problem, it just says x equals. So we're going to say the inflection points. Inflection points are kind of like the maximum and minima from the page before, or from the example before, where minimum is at the bottom of a valley, maximum is at the top of a mountain. Inflection points happen when the arrows change direction. Yeah. So, we have an inflection point here at 0 because our arrow goes from down to up. So definitely 0. Then we have another inflection point at 12 as we have a up then a down arrow. And on your test, the way you're going to write your inflection point is just x equals those two numbers, 0, 12. So again, inflection point means when the arrows change direction. If I would have had this on my number line, the only point of inflection would come from when the arrows change direction, not when the arrows are the same direction. Okay. Done with number 7. Let's keep going. Number 8. Number 8 is a horrible word problem, and it's kind of terrifying. But let's look at Part A. Part A says, find the local extrema for the revenue. Okay, that's like what we did on number 6, where we find the derivative. Then I look in my T-chart for zeros. Then I draw a number line. Yep. Okay. And when it says local, like, yeah, okay. Let's go ahead and start with that. All right. So derivative of this, a number times x, the derivative of that just goes to that number. So the derivative of our revenue is 1,200. And if you're asking, how do you know we're looking at the revenue? Part A says, find for the revenue. So we're looking at the R equation. Okay, so 1,200 minus, exponent comes down and multiplies, and we get 0.48x, subtract 1 from the exponent, 2. Okay, so that's our derivative. Did it. Now we're going to find the T-chart for this. Okay, so we're going to go to y equals, we're going to type in the 1,200 minus 0.48x squared, then we're going to press second graph. And we're going to look for zeros. Ooh, my y values are getting close to 0. Oh, there it is, negative 50. Okay, so we got a 0 at 50. Let's see if I can find, there might be another 0. Let's keep going. Let's go in the positive direction. Look at your y values. They're getting really big, 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 up, 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 up. They're dropping down again. Okay, the y's are dropping down. Keep going, keep going. We're looking for a 0. Keep going, keep going. We're looking for a 0. Oh, there she was. 50. Okay. So, we got 50 and negative 50. Both have zeros. Okay, now it's time for us to draw the number line. Number line. Okay, negative 50 is on the left. Positive 50 is on the right. Okay, but then this problem specifically said, hey, yo, we're only looking at the part of the number line from 0 to 80. So, it's like we're only looking at this part of the number line from 0 to 80, which means that that negative 50 gets thrown out because it's not from 0 to 80. So we're not using a number line with negative 50 on it because that negative 50 is not in between what they told us, 0 and 80. Okay, so let's look at the number line with just 0, 50, 80. Okay. Well, 50 is the number I got from the T-chart. 0 and 80 are the boundaries. Okay, so let's go ahead and pick a point before and after. 49, 51. All right. Then we're going to look at the T-chart for 49, 51. That same T-chart we were on. 49 is 47, 51 is negative 48. Okay. So Across from the 49, we had 47-ish. Across from the 51, we had negative 48-ish. I don't really care about the ish because I just care about the symbols. That 47 is positive, so it's going to go up. On top of the 49, up. Okay? That negative 48 is negative, so we're going to draw a down arrow on top of the 51. Hey, down arrow. Okay? And then we're not going to touch the 0 and the 80. We're not looking for that up in our chart. That's just telling us that that's the only part of the circle we're looking at from 0 to 80. Okay, so we went up and then we went down. Okay, what was the question asking for? Find the local extrema. Well, we got our number line. And what are these arrows doing? They're making a maximum. They're making the top of the mountain. Okay? So this maximum, the top of the mountain, happens at 50. So we have a max at x equals 50. Okay? There's no minimum. Minimums look like 2 arrows pointing down. And we don't have 2 arrows pointing down, so there is no minimum. So we just did part A about the local extrema. Part B says, on which intervals is the graph of the revenue concave up? Okay, let's remember concavity deals with the second derivative. So we need the derivative again. And then we're going to look in the t-chart for zeros and the y's, and then we're going to draw our number line. So local extrema and concavity, it's the same process. It's just concavity comes from the second derivative, or doing it again. All right, let's see here. My first derivative was that up here. 1200 minus 0.48x squared. Okay, let's find the second derivative, because we have to find the derivative again. So the 1200 goes away to a 0 because it's a constant. 2 comes down in front and multiplies with 0.48, and we get negative 0.96x. Okay, now we're going to look at the t-chart, but for this 0.96x. So we're not going to look at the t-chart that's already on my calculator, because that t-chart is for this equation. 1200 minus, yeah, that's not the equation we just wrote down. Okay, so we're going to go to y equals, type in that 0.96x, then press second graph. Alright, so I typed it in y equals, and then I press second graph, and we're looking for where the 0 is in the y. Oh, there it is, at actual 0. Let me see if there's another one. Yeah, okay, there's not another one. So we have a 0 in the y, and across from it is a 0 in the x. Okay, now it's time for a number line. Number line. Put that x value on the circle, on the number line, 0. Pick a number before, -1. After, 1. Look in the t-chart for those numbers. Negative 1 has 0.96. 1 has negative 0.96. So that 0.96 is positive, so we're going to draw an up arrow on top of the negative 1. That negative 0.96 is negative, so we're going to draw a down arrow on top of the 1. Okay, the question was, where are we concave up? Okay, well, concave up comes from the up arrow, which is right here. Okay, so we know that concave up stops here. Concave up stops here, so all the way to 0. And usually we would say like negative infinity to 0 to describe that concave up from the left, negative infinity all the way to 0. But we can't do that this time. The reason we can't do that is because at the very beginning of the problem, they told us that the only part of the number line we want to look at is from 0 to 80. So, this concave up is to the left of 0. That's not, we only want the portion of the graph from 0 to 80. So, since this problem is talking about only from 0 to 80, we're going to say there is no concave up, because the concave up happened before the 0, and this problem is only talking about from 0 to 80. Okay, the concave down looks like it starts at 0, and normally we would say 0 all the way out to infinity. But we're not going to say that, because this word problem told us the number line is only 0 to 80 long. So our concave down is only 0 to 80. Huzzah! Let's pause.